What is the value of h? Okay, let's find out. Statement 1. H squared is equal to 36. So I see what they are trying to do here. So keep in mind two things, because we have an even exponent here. H can be either positive 6 or negative 6, because negative 6 times negative 6 is still 36. And so this is the reason why the square root of x squared is not equal to x. The square root of x squared is equal to the absolute value of x. And so if I were to take the square root of each side here, I would get the absolute value of h is equal to 6, which would get me to h is either positive or negative 6. So this is insufficient because we got two possible values. Statement 2 says h squared plus 12h plus equals negative 36. And so if I add that 36 to each side, I get a quadratic set equal to 0, which is how I like them, because then I can factor them and find my roots. H squared plus 12h plus 36 is equal to 0. So how would this factor? I need two things that multiply to 36 and sum to 12. 9 and 4? No. What do I get? 1 and, so 2 and 18, 3 and 12, 4 and 9. Is this not going to factor? 6 and 6. There we go. So this is h plus 6 squared. Okay, so I see. Is equal to 0. So if h plus 6 all squared is equal to 0, h plus 6 must be equal to 0. So h, in this case, can only be equal to negative 6. And so they're trying to get you to think, you got two possibilities for h from statement 1. Then normally a quadratic will give you two possible values for your roots, in this case h. But this is an exception. This is a special quadratic, and so we only have one solution for h. And so it's not like statement 1. We only have one value here, and therefore statement 2 is sufficient. B is our answer.